Welcome back. In this video, we're going to talk about modeling with trigonometric functions, specifically sine and cosine. We call this sinusoidal modeling. In other words, this video really digs into the idea that if we're giving a context through which sine or cosine can model that information, how do you go about developing a model and then making projections or estimates using that model? Really important to the conversation of modeling is the fact that anytime we can model something with sine, we can also model it with cosine or vice versa. And the reasoning for that is that they are just shifted versions of each other. In fact, we have this identity, and then you can see it from this fact right here, that if we took the sine curve and if we took this and shifted it pi over 2 units to the left, we would end up with the cosine. Or in other words, in terms of transformations, if we took sine of x and added pi over 2 inside the function here, we would get cosine of x. Again, what this is saying, graphically speaking, is if we took this graph and we shifted pi over 2 units to the left, this maximum point right here would start at 0 as it does with cosine, and these would be exactly equivalent graphs. So then the question becomes, which one do we use, sine or cosine? And to me, it's based on this fact right here. The sine function starts at the equilibrium. And again, this equilibrium is this imaginary line that runs right down the average value of the function here. But when I'm modeling, I base it on the fact of, am I using a data point that starts at the equilibrium? Importantly here, sine starts, and again, it really has no starting point, but I like to think of x equals 0 as the starting point. Sine starts at the equilibrium. And then cosine, we'd say, starts at a maximum point. And in fact, I could think of this as a minimum point if I flip this over. So in this fact right here, when I'm modeling, I'm going to use cosine if I want it to start at a max or a min, or what we would call at an extrema. So two important things to take away from this introduction before we get more into the weeds of modeling. First, if we have this sine wave curve, we can always model it with sine or cosine. We're never restricted to just one of them because of this relationship that they're just shifted versions of each other. Though the one that I choose is based on this statement right here. If I'm going to think about my function starting at this average or equilibrium point, I will use sine. If I'm going to interpret the context and think of it starting at a maximum or a minimum value, that's when I'm going to use cosine. Before we get into the weeds with a more complicated example, I want to remind us of our general approach for modeling these sinusoidal curves. First of all, again, we can use sine or we can use cosine. What I really want to emphasize in this demonstration right here is finding the values of A, B, and D. Importantly, the value of C is this shift that I was talking about before, and finding C will be determined by whether we choose to use sine or cosine. But let's talk about these real fast. First, A is the amplitude. The amplitude is the measure of the distance from the extrema to the equilibrium. This value right here is A, and it's exactly the same as this value right here. There's a couple different ways to find amplitude. First of all, amplitude is really the distance from the extrema to the midline or equilibrium. But in practice, the easiest way to find amplitude is if you're given the extrema value. So if you're given your max value and your min value, the distance between those represents 2 times the amplitude. And so the way to find this amplitude right here, again, it starts at 1 if we keep A at 1. But if we want to make it bigger or smaller, what we can do is take the difference between the max and the min. So our formula would be the max minus the min. That will represent 2 times the amplitude, and so we divide that by 2. And remember, the amplitude is directly related to this coefficient A. The only change between the amplitude and the A value might be if you have a vertical flip needing to add a negative, and that would occur if our starting point right here, using a sine curve, if we wanted it to decrease instead of increase first. But let's move on to the next one, which is very closely related to the amplitude, and it's this idea of equilibrium. In fact, you can find these in any order that you want, and they directly help finding the other one. But the amplitude here is this midpoint between the max and the min, or the average of the max and the min. And so if we wanted to find this equilibrium, all we need to do is find the average of the max and min, which is taking the max value plus the min value and dividing it by 2. And to quickly recap that, because they're both very similar, the amplitude is the distance between the max and the min, so I'm subtracting those and then dividing by 2, because it's only half of that distance between the very top and the very bottom of this wave. The equilibrium is that value, it's that vertical shift, our D value right here, and we find that by taking the average of the max and the min. So that covers the A coefficient and the B coefficient in either one of these formulas. The B is related to the period. So in this case right here, we would find the period. So in my model I have here that doesn't have any units. This is one period from this stage to this stage right here, where the curve goes through one full motion of its pattern right here. So we have this period. What we know about the period, and given relation to this B, is that the period equals 2 pi over B. This version of the formula is really useful when we're trying to find the period given a function. But what we want to do is solve this for B, get a fast way for solving this for B. So if we solve this equation for B, what we get is that B, that B coefficient, is 2 pi divided by the period. So in review, if we want to find the A coefficient of our model, we find the amplitude. The only difference between the amplitude and the A coefficient could be some kind of vertical flip, adding a negative. The B value we find by first finding our period and then taking 2 pi divided by our period will give us the B value we want to get the period we have in our model. Finally, if we find the equilibrium, we've then found the D value. That's this equilibrium point that started at 0 and is shifted up or down to the new equilibrium. And finally, we have no generalized approach for finding C. The value of C will be determined by the context and whether we use sine or cosine.